So let's do an example of a problem that could be real life. Here you have a circuit breaker that you think is bad. It just keeps tripping. It's rated at 20 amps, and you know that there are three devices, and the ratings are 100 watts, 1200 watts, and 1080 watts. So you want to figure out, is this circuit breaker bad? So we have given, we'll call P1 is equal to 100 watts, P2 is equal to 1200 watts, and P3 is equal to 1080 watts. And since we're talking about a home circuit, our V, call it V source, is 120 volts. So our current is going to be equal to the sum of our powers divided by our voltage of the source. And that's going to be 100 watts plus 1200 watts plus 1080 watts divided by 120 volts. And that gives me 19.833 amps. So the question is it bad? And the answer is we don't know. Why? Well, the circuit breaker could be old. And in that case, it would need to be replaced. Our devices are what we've got hooked up. Devices may require more power than rated. Because they may be old, or they may be new. And I mean, the rating is just an average. It's kind of hard to say specifically, but it should be under. But you don't know. The devices could be bad. You could have a wiring problem. Some kind of short. You could have a number of things. But what is the easiest solution to test it out? Well, that's remove a device. And typically you'd want to remove the largest one. If you remove the 100 watts, it's not going to do much. But remove the largest to get the biggest bang for the buck and see what happens. If the circuit breaker keeps tripping after that, then you know it's probably going to be the circuit breaker. If the circuit breaker doesn't trip, then it's probably got too many things hooked to the circuit. But I just want to bring up this point. Many people see, oh, it's under 20, it's fine. You can't say that. It's too close to call. And so you really have to go to a secondary method of testing whether it's actually a good circuit breaker or not.